Okay, guys, this video I'm going to teach you stationary waves. This wave is a progressive wave, that means energy carried from one place to another, right? Progressive wave. Okay. From this to here, any point carries energy. And when it collides against some solid boundary, wave gets inverted and travel in the other direction. That's it. But when these two waves interfere with each other, don't get the misunderstanding. This wave and the other wave just overlap with and produce this one directly. No, no, no. It's a very long process, right? Different process, multiple interference and diffraction and many. So here, this is not according to A level. So no need to worry. If you remember it like this way, very simple way, like this forward wave, like for the right hand side one, inverted to the left hand side one, and collapse with each other and make this wave. It's fine. But it's not the truth. But if you can remember like that, no problem. Nobody is going to question you. So remember, whatever the way, that's the most important thing for the A level. Advanced, says advanced, but it's not extremely. The university level, you will be analyze this and find out the real reason how is this formed. So now let's come back to our topic. So this type of this is all due to what destructive interference of these two waves forms a point with no vibration at all. You can hold the point of this type of vibration in the standing wave by your finger without distorting the wave pattern. But if you touch the other end, if the string is really fast moving, it might cut your finger, right? Here, the nodes, these vibrationless parts are known as nodes, like the just a node in a loop, nodes, anti-node. It's like your extremely enlarged belly. Thingy is what? Top of your head, like thingy, anti-node. Nodes, anti-node. Okay. Let me explain you the very next part simply. Now, how does this wave may look like? I just got the one stuff like here. I'm going to detach these two waves. Now see, what is this actually? Now it is a wavelength. See that the other one is also a wavelength. So when you see this type of two loops, always one loop is half the wavelength. Remember that one loop is always a half wavelength. If you get two of these, it is definitely the length is equals to wavelength. Always remember, one loop is always the length of that one loop, or loop is lambda over 2. Now let me rejoin this one and show you. See, now it may look like a very weird shape like two loops, but when you detach, you can see it's none other than the wave length. Okay. Now let me explain you the waves in the strings. Waves can get tense like this. The speed of the wave is just depending on this equation. No derivation here. University level thing. You just need to remember. Over mu. T is the tension, while this one is what? Mass per unit length. Okay. So let me explain you with one more sophisticated example. If this string has a length of L and a mass of M, what is mu? M over L. So sometimes you may get this type of question. Who knows? Cross-sectional area as A and the length of L and the mass of M with the density of T. How? How can you just apply this in? You know the volume. You can get the volume of this one. Volume is what? Area into length. Area into length. Okay. So you know that density equals to mass over volume. So mass is what? Area, sorry, density into volume. Density equals rho, and the area is A over L. Now this is what mass per unit length. What is the factor I want to find? What is it? So mass over length mass is now this equation, and length is just L itself. Once we apply, see the result, how beautiful the result is. Rho A L over L, L and L cancel off. Mu is what? Rho A, or uniform cross-sectional string with uniform cross-sectional area. If you get a question, don't get panic. Apply these results. Very simple. Now the whole equation is going to change. What is the equation now? Tension equals to rho A. And tension can also be changed like in this manner. Let me explain you. So if the tension is got tensed, passing it or this string over certain pulley, it has a mass of capital M. The force applied is mg, capital Mg, downward. The tension is nothing other than in here what? Tension equals to capital Mg. So what is the derived equation now? Equals to G means capital Mg over mu. So this can also be changed in another step. How? Mg over M over the simple M for the mass of this one. Many changes you can create with your existing knowledge. All the things are not in your textbook. So you have to adhere to these results as well. Good. Now let me explain you something like the fundamental tone. Right. In a stream set, you may get this type of results. Right? So in a string, if you get the wave pattern here, what is the loop? I told you it's always lambda over 2. So L equals to lambda over 2. What is your result? Now you can get the lambda as when you cross multiply L. It's one of the results in your book. Next one, lambda over 2. This one is so lambda over 2. This whole is lambda. So lambda equals to L directly for this one. Now in the next one, let's see. Okay. Now have a really good look at here. If you see this type of thing, lambda over 2, lambda over 2, lambda over 2. So what is the whole length now? L equals to how many lambda? 3 lambda over 2. There are 3 such fractions here. What is the wavelength? L over 3. Very simple. The very next one. Lambda over 2, lambda over 2, lambda over 2, lambda over 2. That means the whole length is what? 2 lambda. Now lambda is what? L over 2. Really very simple to understand. If you don't understand, just please the video, go back, see that. Okay, very important thing. Fundamental tone. It's like a cracking a guitar string with its natural frequency. Speed of sound in the string is Tv, and if not, it's a fundamental tone according to the length of L, how it is going to be. Let me just explain you very simple manner. It's really simple. How? How would look at V equals to F lambda is my equation. Equals to F lambda. Okay, I told you in this one, what is it? L equals to lambda over 2, lambda equals to 2L. I saw you earlier. Now we just apply this to here. And what is V? V equals to what? Square root of T over mu. My equation is what now? If not lambda, if not 2L equals to square root of T over mu. Now the equation becomes something like this. 1 over 2L when it's cross multiply times T over mu. This is the first and foremost results that you can obtain from this equation. Okay, and you can make many changes, but I'm not expecting that type of deeper questions for you to get in the exam. But I'll show you 1 over 2L. This is just for solving mg over rho A. It can also be that now you might really confuse what the heck he wrote here. If you see, so just see here the mass per unit length is nothing other than rho times A. Additional result, additional stuff. Okay. Now let me explain you in the next one. Is it very basic? First overtone. What is first overtone is going to be this one. This is what the first overtone. Length is L. This one is L. So what is my equation? P equals to F lambda. From the other one, T over mu. F1 lambda equals to T over mu. So lambda equals to just L. The equation looks like this. 1 over L times what? T over mu. So I can show you one big result. Earlier we found like not equals to 1 over 2L times T over mu. If I want to get 2 to bottom, I have to multiply that by the same. What can I do now? 2 up times 1 over 2L square root of T over mu. What is the result? This one is F0. So F1 is in the terms of what? 2F0 and series of result. Result. This is something too extra for you. But if you are really curious, write the next step as well. Like for the what? Next thing, second overtone or the third harmony. This is the first overtone, that is the second harmony. Fundamental tone is the what? First harmony. Okay. So what is it? This one, F2. Just derive an equation. I will just give the start. Lambda L equals to P lambda over 2 lambda. Apply the equations. Finally, you may get the F2 value as 3. Many multiple results are there. I hope you understand this one and you know what to do now. Subscribe to the channel, share it with your friends. Thank you very much.